Okay, so we are going to do the entry task for either 125 or 126, depending on what day your class is. So I already started underlining this and I realized, wait a minute, it's not recording. So let's try again. A pole vaulter lands on a mat coming to a stop in 1.25 seconds. That's a time. If they have an impulse of 150 Newton seconds, what is the force acting on it? So we're looking for force. We have an impulse and a time, so we're using that impulse equation, the J, F, and T. So our J is our impulse, and that's given to us at 150 Newton seconds. Our time is 1.25 seconds, and we're looking for force, so that will be X newtons. So we need to find out what equation we're going to use. If we're looking for F, remember with the circle, cover up the F and get J over top of T, or J divided by T. So our equation will be F equals J divided by T. So now we just plug it in. So X newtons equals, my impulse is on top, 150 Newton seconds, dividing that by my time of 1.25 seconds. The seconds cancel. I'm left with a Newton. That's what I need. So now I just plug it into my calculator. So I'm going to get 150 divided by 1.25, and that gives me 120 newtons of force. Okay. So, second one, what is the momentum? So now we're doing momentum of a 2,600 kilogram boat traveling 28 meters per second. So momentum is the mass and velocity equation. So P, M, and V are our variables we'll need. Let's figure out our equation. If we're looking for momentum, cover up P. Oops, shadow on that. You can't see very well. Let's do it this side. Cover up P, you get M multiplied by V because they're next to each other. So that's our base equation. P equals M times V. So our momentum is what we're looking for. Remember, it's in kilograms meters per second. So X kilograms meters per second, because we multiply a mass times a velocity. Kilograms times the meters per second. Our mass is given to us at 2,600 kilograms, and our velocity is 28 meters per second. So now we just plug it into the equation. X kilograms meters per second equals my mass, 2,600 kilograms, times my velocity, 28 meters per second. Now I just have to multiply 2,600 times 28 equals 72,800 kilograms meters per second. Kilograms times the meters per second. Okay, there we go. Number 3, a runner is going 2.5 meters per second and accelerates to 5.5 meters per second over 2 seconds. What is the force they apply to the ground to accelerate? So remember, this one we're using the force multiplied by time, which is the impulse, equals mass times change in velocity, which is change in momentum. So impulse equals change in momentum. We need 4 variables though, a force, a time, a mass. And I'm just going to put the delta V there because it is giving us 2 velocities here, 2.5 and 5.5. So we actually have to calculate the change in velocity. So we have a 75 kilogram runner. That's their mass. So 75 kilograms is their mass. They're going 2.5 and they accelerate to 5.5. So we need the change in velocity. So remember, to get change in velocity, it's going to be final velocity minus initial velocity. So that'll be final velocity of 5.5 meters per second minus 2.5 meters per second, which is our initial velocity. That's going to give us 3 meters per second. So that is our change in velocity that we're going to use. Okay, our time is 2 seconds, and our force is what we're looking for. They want to know how much force. So we need to know the equation we're going to use when we're looking for force. So if you remember from last week, if I'm looking for F, I got to get rid of the T on the same side of the equation. I need F by itself. So we want F by itself. So to get rid of T, I have to move it by dividing it out on this side and dividing it on this side. Okay, so my new equation is going to be force equals mass times change in velocity divided by time. So now I'm going to take all this information and plug it in here. So my force is X newtons. I'm going to have my mass, which is 75 kilograms. I'm going to multiply that by my change in velocity. That's the new velocity I just found. I'm going to divide that by my time of 2 seconds. Okay, so now I have to just plug it all into my calculator. So 75 times 3, you could probably do that in your head, but let's just make sure we get it correct. 225, remember that's a kilograms times the meters per second. Dividing it by 2 seconds, okay? And so that's going to give me a kilograms meters per second, which is a kilograms meters per second squared. Remember that? So that's a Newton. That's going to give us a force. So let's go ahead and divide that by 2. And we get 112, so I'm running out of room, 0.5 newtons. So remember, a kilograms meters per second divided by another second per second is a kilograms meters per second squared, which is a Newton. Okay, last one. A 25 kilogram box experiences 820 newtons of force for 0.15 seconds. What is their change in velocity? I'm looking for the velocity this time. So we still need a F, T, M, and delta V. Okay, and I'm going to write them all out. Okay, so my force is what are 820 newtons. My time is 0.15 seconds. My mass is 25 kilograms. And I'm looking for my change in velocity. My hand's hanging off the table. I don't have support, so my handwriting might get bad. So that's going to be x meters per second. Okay, so I need to, let's see if I can give myself a little more hand space. Find my equation. So if I'm looking for change in velocity, I got to get rid of the m. I need the v by itself. So I've got to divide out the m on both sides. So I end up with a new equation of change in velocity equals force multiplied by time divided by mass. So my change in velocity is x meters per second equals my force, 820 newtons, multiplied by my time, 0.15 seconds. Divide that by my mass, 25 kilograms. So now I plug it all into the calculator. So remember, multiply everything across the top first. Oops, there we go. 820 times 0.15 equals 123 Newton seconds. A Newton times a second. Divide that by a kilogram. And remember, a Newton is a kilograms meters per second squared. Okay, so if I'm dividing out my 25 kilograms, I'm left with a meters per second squared right here, and then I multiply that by a second over 1, and that gets rid of the squared. So it leaves me a meters per second, which is what I need, a meters per second. Okay, so 123 divided by 25 equals 4.92 meters per second. That is the change in velocity that this this box experienced when we added a force for 0.15 seconds. Okay, and that is the end.